Have you ever looked up at the night sky, filled with countless stars, and wondered just how far it all goes? Does it go on forever, or does it somewhere just stop? This is one of the biggest questions we can ask. It's a question that has puzzled thinkers for thousands of years, from ancient philosophers to modern-day astronomers. The universe is vast, almost beyond our ability to imagine. We see galaxies stretching out in every direction we look, but is there an end to it all? Is there a cosmic wall at the edge of everything? The search for this answer takes us on a journey through space and time, using the laws of physics as our guide. Thinking about infinity can really make your head spin. If the universe goes on forever, that means there's an endless supply of stars, galaxies, and perhaps even worlds like our own. It's a staggering thought, but if it doesn't go on forever, what does that mean? What would you find at the edge? A giant sign that says, "Universe ends here." That seems unlikely. The concept of an edge is tricky. An edge is a boundary between one thing and another. If the universe has an edge, we must ask what lies beyond it. This question itself might not even make sense in the context of the cosmos. Our human intuition, built for life on a small planet, often fails us when we try to grasp the true nature of reality on such a grand scale. To explore this grand question, we need a spaceship. Not a physical one, but a spaceship of the mind. Our vessel is powered by curiosity, and navigated by the light of science. We will travel across the fabric of spacetime itself. We will see how light from distant galaxies carries secrets about the shape and size of our universe. These ancient photons, some traveling for billions of years, are cosmic messengers. They tell us a story about the early universe, its history, and its ultimate fate. By studying their journey, we can start to piece together the puzzle of the cosmos and ask whether our home is a finite island or an infinite ocean of existence. Before we launch on our cosmic journey, let's consider what we're looking for. We are trying to understand the overall shape, or geometry, of the entire universe. Is it flat like a sheet of paper that extends to infinity, or is it curved in some way we can't easily picture? The answer has profound implications. It could tell us whether the universe will expand forever, or one day collapse back on itself in a big crunch. It's a detective story of cosmic proportions, and the clues are written in the light from the farthest reaches of space. So, buckle up. The cosmos awaits, and it is full of wonders and mind-blowing possibilities that challenge everything we think we know. To understand how the universe could be finite but not have an edge, let's think about something closer to home: the surface of the Earth. Imagine you are an ancient sailor, setting out on a great voyage. You believe the world is flat. If you sail far enough in one direction, you expect to fall off the edge. But you never do. Instead, you keep sailing, and one day, you arrive right back where you started. You have circumnavigated the globe. This simple yet profound discovery changed our understanding of our world. It proved that the Earth's surface is finite. It has a measurable area, but it has no edge to fall off of. You can wander its surface forever without ever hitting a boundary. Now, let's apply this idea to the entire universe. What if the universe is like the surface of the Earth, but in more dimensions? Our universe has 3 spatial dimensions: length, width, and height. A 4-dimensional being could see our 3-dimensional universe as a hypersphere, just as we can see the 2-dimensional surface of the Earth as a sphere. If this were the case, our universe would be finite. It would have a specific measurable volume. But just like the sailor on the globe, you could travel in a straight line in any direction and never hit a wall. Instead, after an incredibly long journey, you would eventually end up right back where you began your cosmic trek. This concept is mind-bending because we can't easily visualize a 4th dimension. We are trapped within our 3 dimensions of space. We can't step outside our universe to see its overall shape, but we don't have to see it to test the idea. We can use the principles of geometry to look for signs of curvature from within. If you draw a giant triangle on the surface of the Earth, the angles will add up to more than 180 degrees. This is a clear sign of a positively curved surface. In the same way, astronomers can look for giant triangles in the cosmos to measure the geometry of spacetime itself. This idea of a finite, boundless universe solves the problem of what lies beyond the edge. There is no beyond. The universe contains everything. It's a self-contained system. If you were to point a super powerful telescope in one direction, it might be possible to see the back of your own head after your line of sight had wrapped all the way around the cosmos. Of course, the universe is expanding, which complicates this picture. The light would have to travel for billions of years across an ever-stretching fabric of space, but the principle remains. The universe could be a finite place, yet you could wander it for eternity. So, how do scientists actually measure the shape of the entire universe from our tiny perch here on Earth? We can't exactly roll out a cosmic measuring tape. Instead, we use light. The most powerful tool we have for this is the oldest light in the universe, the cosmic microwave background, or CMB. This is the faint afterglow of the Big Bang, a thermal radiation that fills all of space. It was released when the universe was only about 380,000 years old. This light has been traveling across the cosmos for over 13 billion years to reach us, and it carries a snapshot of the infant universe. The CMB isn't perfectly uniform. It has tiny temperature fluctuations, or spots, of slightly hotter and colder regions. These spots are the seeds of all future structures like the galaxies we see today. Scientists have a very good understanding of how large these spots should have been in the early universe. By measuring how large these spots appear to us now, we can determine the geometry of the space they have traveled through. Imagine drawing circles of a known size on a balloon. If you then inflate the balloon, the circles will stretch and appear larger. If you draw them on a saddle-shaped surface, they might appear distorted in another way. We can think of this using a simple analogy with triangles. On a flat sheet of paper, the angles of any triangle always add up to exactly 180 degrees. This is Euclidean geometry, the kind we all learn in school. If the universe is flat on a cosmic scale, then the giant triangles we can form by observing distant galaxies should also have angles that sum to 180 degrees. However, if the universe is positively curved like the surface of a sphere, the angles will add up to more than 180 degrees. If it's negatively curved, like the surface of a saddle, the angles will sum to less than 180 degrees. Astronomers use the known size of the CMB spots as one side of a colossal triangle, with Earth at the opposite vertex. So far, our most precise measurements of the CMB, from missions like the Planck satellite, have shown that the universe is remarkably flat. The angles of our cosmic triangles appear to add up to 180 degrees, with a very small margin of error. This suggests that the universe is either truly infinite, extending forever in all directions, or it is so immensely large that any curvature is undetectable to us. It's like being an ant on the surface of the Earth. The planet is so big that your immediate surroundings look perfectly flat. The universe could be curved, but on a scale so grand that our observable patch appears flat as a pancake. When we talk about the universe, we need to be careful with our words. There's a difference between the entire universe and the observable universe. The observable universe is everything we can, in principle, see from Earth. There is a fundamental limit to how far we can look. This limit isn't set by the power of our telescopes, but by the speed of light and the age of the universe. The universe is about 13.8 billion years old. This means that light from any object farther than 13.8 billion light-years away has not had enough time to reach us yet. Anything beyond that distance is, for now, completely invisible to us. This creates a spherical bubble of space around us, with Earth at the center. This sphere is what we call the observable universe. Its edge is called the cosmic horizon. It's not a physical wall, but a horizon in time. When we look at a galaxy 10 billion light-years away, we are seeing it as it was 10 billion years ago. When we look at the cosmic horizon, we are looking back to the very beginning of cosmic time. Every observer in the universe, on any other planet in any other galaxy, has their own observable universe with them at the center. Their view might overlap with ours, but they would see parts of the cosmos that are forever hidden from us, because the universe has been expanding since the Big Bang. The observable universe is actually larger than 13.8 billion light-years across. The space that once emitted the light we see today has continued to expand away from us. Taking this expansion into account, the current diameter of the observable universe is estimated to be about 93 billion light-years. That's an almost incomprehensibly vast distance. And yet, this enormous sphere of galaxies, stars, and planets might only be a tiny, insignificant fraction of the entire universe. The whole universe could be trillions of light-years across, or it could truly be infinite. We have no way of knowing what lies beyond our cosmic horizon. This is a crucial point. All of our measurements about the flatness and shape of the universe apply only to the part we can see. We are assuming that the rest of the universe, the part beyond our horizon, is similar to our local patch. This is a reasonable assumption known as the cosmological principle, but it is still an assumption. The universe beyond our view could be wildly different. It could have a different shape or structure. We are like a sailor in the middle of a vast ocean on a foggy day. We can see a certain distance in every direction, and the sea looks flat. But we can't know for sure if just beyond the fog, there lies a massive cosmic waterfall, or the shore of another continent. So, what is the final verdict? Is the universe infinite or not? The honest answer is, we don't know for sure. Our best evidence points to a flat universe. If it is perfectly flat, then the simplest explanation is that it is infinite. It just keeps going. But it could also be finite, in a way that cleverly mimics flatness. Imagine taking a flat sheet of paper and rolling it into a cylinder. The geometry on the surface is still flat. Parallel lines stay parallel, and triangles have 180 degrees. But it is finite in one direction. If you travel around its circumference, you return to your starting point. The universe could have a similar, more complex topology, like a giant cosmic donut or some other bizarre shape. If the universe is finite, even if it's very large, there might be a way to prove it. If space wraps around on itself, then light from a distant galaxy could reach us from multiple directions. We might see the same galaxy in different parts of the sky, appearing at different stages of its life. Astronomers have actively searched for such repeating patterns in the cosmic microwave background and in the distribution of galaxies. Imagine seeing a pattern of cold and hot spots in the CMB on one side of the sky that is perfectly mirrored or repeated on the other. This would be bombshell evidence that the universe is finite, and we are seeing the same structure from different angles. So far, these searches have come up empty. We have found no convincing evidence of a repeating universe or a cosmic hall of mirrors. This either means the universe is truly infinite, or it is finite, but so much larger than our observable bubble that the light hasn't had time to wrap all the way around yet. It could be that the real universe is thousands or even millions of times larger than the 93 billion light-year sphere we can currently see. If that's the case, we might never find the evidence we are looking for. The ultimate truth about the size of the cosmos may be forever locked away, beyond our cosmic horizon. And so, we are left with a sense of profound wonder and humility. The universe could be an endless expanse of space and time, or it could be a finite, self-contained loop that is vaster than we can measure. It could even be part of a multiverse, just one bubble among an infinity of other universes, each with its own laws of physics. The truth might be stranger than any of our theories. For now, the question remains open, inspiring us to keep looking up, to keep questioning and to keep exploring. The search for this answer is, in itself, one of the greatest adventures of the human mind. The cosmos does not give up its secrets easily.